Hello and welcome to today's lab. Within your VCL session, navigate to the Blackboard course webpage. Along the left-hand menu, select Data, and navigate to the States dataset. And it will be prompted to either open or save that dataset. Click Open, and this will start your session of SPSS. Today's lab builds on our understanding of linear regression and introduces how to produce graphics for regression. Remember that regression is appropriate if you are working with interval or ratio level independent and dependent variables. Let's review how to use regression in SPSS. Suppose you're interested in the gender disparity in state legislatures and wanted to explain what factors may influence variation in the percentage of female legislators across states. We theorize that perhaps knowing that states' percentage of high-frequency church attenders explains a state's percentage of female legislators. Alright, in SPSS, let's look at this relationship. So go to Analyze, down to Regression, and select Linear, and we'll sort our variables here, and scroll all the way down to the bottom of the list, and we're going to select the percentage of women in the legislature in 2010 is our dependent variable, and all the way up in the top we have the percentage of high frequency church attenders. Select that into the independent box. Alright, go ahead and click OK. Alright, working from the top down, look at your R square. Remember that it indicates the exact amount of variation in the dependent variable explained by the independent variable. In this example, R square is 0.419, meaning that 41.9% of the variation in our dependent variable is explained when we know values of our independent variable. Now look at the p-values. You have two here, one for the model, or the F statistic, and one for each coefficient. Both are significant in the example here. And we see that our beta value for our independent variable is negative 0.47, meaning that for each additional percentage of high church attenders, we would expect the percentage of women legislators in that state to decrease by 0.47 percentage points. So what can we conclude from this test? We can conclude the model is significant in 99% confidence. Our independent variable of percentage of high-frequency church attenders is also significant at 99% confidence, and our negative relationship is confirmed. A 1-unit increase in high-frequency church attenders corresponds to a 0.47 decrease in percentage of women legislators in a given state. Great. Now let's minimize out of this output window. Alright, so now let's generate the appropriate graphic for linear regression, what is called a scatter plot. A scatter plot is a graphic that maps our observations with the independent and dependent variable values on a Cartesian plane. Alright, go to Graphs, Legacy Dialogues, down to Scatter, choose the Simple Scatter option, and click Define. And we'll sort our cases here. Alright, now choose the percentage of women in the legislatures in 2010 as our dependent variable in the y-axis. And all the way up on top here are high frequency church attenders as our independent variable into the x-axis. And as is the case when we generate any graphic, we'll add a title to the graphic. In this case, it's percentage of women in the legislature by percentage church attenders. And in the footnote line, we'll just put the states dataset 2008 and click Continue, and click OK to generate your graphic. Alright, this produces a scatter plot for our two variables, with values of the independent variable along the x-axis and values of the dependent variable along the y-axis. The data points on the scatter plot indicate a case, or the xy coordinates for our independent variable and dependent variable. Just from observing how these data points distribute, we notice that there seems to be a negative relationship here. As we increase in values of our independent variable, or as we move from left to right on the x-axis, there is a decrease in values of the dependent variable. Recall that our Pearson's R value indicated a strong relationship, and our beta coefficient for our independent variable suggested a negative relationship. Remember that regression produces a line that best fits given the distribution of all the data points. That is, a line that is minimizing the amount of squared error between data points. To view the regression line for this relationship, double-click on the graphic to open up the chart editor. So go ahead and double-click on the chart, or the graphic to open up the chart editor. So in the chart editor, you can add a best fit line using the button on the top menu. This will draw the regression line through the data points. SPSS will also place the equation for that line on your scatter plot. Very good. To review, we've reviewed how to use regression to test a relationship between two interval or ratio level variables, as well as introduced how to generate and interpret a scatter plot for our regression analysis.
Great job, students! You can take this opportunity to practice with either the states dataset or the world dataset, both of which have excellent interval and ratio level variables for you to play with. When you're ready, move on to multivariate regression